Hello everyone, today we are going to discuss STP. As we know that STP is a layer 2 protocol which is used to avoid loop and provide path redundancy. STP is by default enabled for all the VLAN and ports. I am assuming that we know about STP and this is just a revision session on STP. Okay. So first, first question comes how STP works. As we know that STP will elect a root bridge based on bridge ID. So here bridge ID is a combination of priority and MAC address. Priority is 0, that's why switch 1 is selected as a root bridge. Now we have to elect one root port. So a root port will be elected on non-root bridge. So here either Ethernet 1 by 2 will be elected as a root port or Ethernet 1 by 1 will be elected as a root port. And here is the criteria to elect root port. So to elect root port, first of all, we will check the path cost. Let's assume path cost is 2 from both the side. So in that case, it will go with other criteria, which is lowest sender bridge ID. We are receiving STP BP dues from switch 1 on both the ports. So sender bridge ID is also same. Now the lowest sender port ID. So basically, uh, port ID is a combination of port priority and port ID. So let's assume it is default. So it will go with port number. So and again keep in mind that we are going to have a look on sender port number. So here we are receiving the STP BP dues from Ethernet 1 by 1, and on this we are receiving from Ethernet 1 by 2. Therefore Ethernet 1 by 2 on switch 2 will be elected as a root port. So the other one, lowest local port ID, we can see like everything is matching here up to this mark. Then what is the case, or when we can come across lowest local port ID? So here is the case. For example, I have connected two switches using hub. So in that case, like path cost is same, sender bridge id will be the same this switch, and sender port id will be the port number on this port, so that is also same. In that case it will go with local port id, which is the again combination of priority as well as port number. I am considering priority is same, and therefore fs0 by 1 will be elected as a rp. Does it make sense? Okay. Now I have another question here. Is it possible to have a blocking port on root bridge? You may answer like no. In that case, I would like your attention on this particular topology, where I have one switch which is back to back connected via FS0 by 1 and FS0 by 2. Or you can have a look. I have one hub which is connected via FS0 by 1 and FS0 by 2. So one port will be in blocking state. Why? Because now this is becoming one segment. This is becoming one segment. One is dp, one is in blocking. So there is a possibility to have a blocking port on root bridge, but it depends on situations like here, how we have connected. So these are the two possible way or situations where blocking port can exist on root bridge. Okay. Now let's come to the STP states. We know that we have five states: disable, blocking, listening, learning, and forwarding. And we know in blocking we can only receive the BPDUs. We will not send the BPDUs. Listening, we can send and receive the BPDUs. Learning, we can send and receive the BPDUs, as well as we'll learn the MAC address. In forwarding, we can send and receive the BPDUs, as well as we can forward the traffic as well. Now here is my question. Let's assume I have connected switch 1 and switch 2 at the same time. What will be the first state of STP? If you have answered blocking, yes, you are right. So if blocking is my first state, then how these two switches are going to receive the BPDUs? Because in blocking, we are going to receive the BPDUs. We are not going to send the BPDUs. How STP is going to converge? They both has to stay in blocking, right? We are not going to generate, or we are not going to send STP BPDUs in blocking state, and first state is blocking itself. So answer is basically whenever we connect two switches at same time, port will initialize or will come in connected state and move to the blocking state for very brief moment, as like we are not seeing the BPDUs for time being. In that case, switch 1 or switch 2 will assume that there is no device which is sending BPDUs. So let's move and to the next state and elect himself as a root brace, and will do the port role changes accordingly. Now the other question is, what will happen if we have configured BPDU filter and BPDU guard on same port? As I'm assuming that we know about BPDU guard and BPDU filter, let's revise. BPDU guard is a feature which we enable on end user port, where we are not like we are assuming we will not receive the BPDUs. Like we are sure, like system is connected, printer is connected, any device which does not generate the BPDU, we are sure we will not going to receive the BPDU from that particular port. We will enable BPDU guard. So whenever port like if we receive BPDU, that particular port will be in error disabled state. Same way BPDU filter is we are not going to send the BPDUs. If we receive the BPDU, we are going to ignore the BPDUs. Again, these things depends where we have configured BPDU filter, at interface level or at global level. But keep in mind, whenever you are going to enable BPDU filter, means you are going to disable STP, which is dangerous. So be very careful while implementing BPDU filter. Now let's come back to the question. I have one port where I have configured BPDU guard as well as BPDU filter. Now what will happen? So basically whenever we have BPDU guard as well as BPDU filter on same port, in that case BPDU filter will take the precedence over BPDU guard. That's why in this output we can see BPDU guard and BPDU filter is enabled, but we are not sending the sending the STP BPDUs. And port is up, it is not in error disable, even though I am connected on other end is switch, but still port is up. Okay, now I have another question. Let's assume I have 4 VLAN on switch 1, 4 VLAN on switch 2, 10, 20, 30, 40, 10, 20, 30, 40. Now what will happen by default? One will be like a root brace. Let's assume switch 1 is the root brace. In that case, what will happen? One will be in one link will be in forwarding, another link will be in blocking state. So I am not able to utilize Ethernet 1x2 link, correct? Because it is in blocking state, and it will be always idle until unless there is a failure event on Ethernet 1x1. So is there any way to where we can do the load balance in between Ethernet 1x1 and 1x2? So you may have the opinion we can pass 2 VLANs over Ethernet 1x1 and another 2 VLANs on Ethernet 1x2. Cool. But the problem with this solution is, if that particular link, for example, I have passed 10 and 20 on this link, 30 and 40 on this link. If this link goes down, it means we will lose the connectivity for those 2 VLANs. Okay, that's fine. Now that is not a appropriate solution. So you may have the choice. You make switch 1 a root brace for VLAN 10 and 20, switch 2 for 30 and 40, right? In that case, what will happen? Like root brace is changing. But again, in this way, port will be again blocking here. It will be blocking for 1020, this will be blocking for 3040, right? No changes. Now still we are not able to achieve load balancing. So now you can manipulate the path cost, like for VLAN 10 and 20 increase the path cost, or vice versa. Now here I have a question. Is it possible to change path cost for specific VLAN? Okay, let me give this answer after this slide. Okay, now let's assume you are not supposed to change or manipulate the path cost. Is there another way? Yeah, we do have. Like, we can manipulate the port priority. Again, is it possible to change particular port priority for particular VLAN? Yes, we can change the cost and priority values based on VLAN as well. Like VLAN X is the VLAN. We'll discuss few other things in another video. Thanks for your time. Have a nice day.